Hello students, welcome to the class. So today we will do about change of state. We know that there are three states of matter: solid state, liquid state and gaseous state. It means the substance exists in three states mainly: solid state, liquid state and gaseous state. And the substance can easily be changed from one state to another state, like solid state to liquid or liquid to gaseous state, or may be converted from gaseous to liquid or liquid to solid. So that is what that is related to change of state. For example, ice. Ice, when we will heat it, then the ice will melt and convert it into the liquid water. So that is what here ice, when converted into the water, the solid ice converted into the water, then we call it melting. Solid state to the liquid state, we call it melting. Ice to water, and then water, when it is heated, then it is converted into steam, or we call it water vapor. Steam, that is what gaseous state of water. So liquid changes into the gaseous state, and that we call it boiling or vaporization. Again, what happens, this steam, when cooled down, then it will be converted into the water, and that is what, that is condensation or liquefaction, or water converted into the ice, and that is what, that is freezing or solidification. That is known as the freezing or solidification. Not only the ice converted into the liquid form, that is the water, or water changes into the water vapor state, even other substances also change from one state to another state, like wax converted into the liquid wax or molten wax on heating, and the molten wax converted into the wax vapor on further heating. So it's not that only the ice, or that is the water, change from one state to another state. Even the other substances like wax, plastic or polythene, they can also be converted from one state to another state: solid to liquid, liquid to gaseous state. So this is what, this is related to change of state. So we will discuss in detail about this today. And what are the factors responsible for change of state? You think that only due to change of temperature the substance changes from one state to another state. No, if even by the change of pressure, the substance can change from one state to another state. Actually, these are the arrangement of the particles which are responsible for change of state. These are arrangement of the particles which are responsible for change of state. If the particles are far apart, then what happens? The substance changes from solid to liquid and liquid to gaseous state. And if by any method the particles can bring the particles can bring closer to each other, then what will happen? The reverse happens. The liquid changes to the solid state, or gaseous substance changes to the liquid state. So the change of state, first is we will discuss about the melting. Melting melting is a process where the substance changes from solid state to liquid state at a particular temperature, and that is what, that is the melting. And this solid state to liquid state, it takes place at a particular temperature, and that particular temperature is known as the melting point of the substance. For example, ice melts converted into the water at 0 degrees Celsius. So 0 degrees Celsius is the melting point for water. Now I will explain to you that how a substance changes from solid state to liquid state with the help of molecular theory or kinetic molecular theory. According to kinetic molecular theory, We know that solid substance, within the solid substance, the particles are very close to each other. Means the particles are tightly packed. And within the liquid substance, when the substance is in the liquid state, at that time what happens? The particles are far apart within the container. Okay. So here the particles are very close to each other, but here the particles are far apart. Actually, we know that when we heat the solid substance, then it is converted from solid to liquid state. So actually, why this happened? When the solid is heated, at that time what happens? The average kinetic energy of these particles increases. Since the kinetic energy increases, so what happens? The molecule starts vibrating about their mean position with greater amplitude. Now, when they start vibrating at their mean position with greater amplitude, then intermolecular space between the particles increases. And when intermolecular space increases, intermolecular force of attraction decreases. And now what happens? The particles are free to move, but free to move within the substance or within the boundary of the container. They cannot go beyond this. So they move within the boundary of the container or within the substance. So in this way the substance change from solid state to liquid state, solid to liquid state, and we call it melting. And the temperature, the fixed temperature at which it will be converted from solid state to liquid state, that is known as the melting point. Even I will increase the volume, means I will release the pressure. At that time also what will happen? The particles will move apart. The particles will move apart, so intermolecular space decreases, sorry, intermolecular space increases and intermolecular force decreases, and the particles becomes free to move within the substance, and it will be converted from solid state to liquid state. So that is all about how the substance change from solid state to liquid state on kinetic theory. Here the points are written, you can go through. That first point is it is that on heating, average kinetic energy of the molecules increases. Molecules start vibrating about their mean position with greater amplitude. Therefore, intermolecular space increases, and when space increases, intermolecular force decreases, and particles become free to move within the substance, and therefore the state of the substance changes from solid state to liquid state. Now next we will discuss in detail about the boiling or vaporization. Okay, during boiling what happens? Boiling is a process in which what happens? The substance changes from liquid state, liquid state to gaseous state. That is what? That is boiling. Even boiling is known as vaporization, and this takes place when it will take place? When it is heated. So the process in which the liquid substance a substance changes from a liquid state to the gaseous state at a particular temperature, and that process is known as boiling. And the temperature, the fixed temperature at which the substance changes from liquid state to gaseous state, that fixed temperature is known as boiling. Now this process, that boiling process, we can explain it with the help of kinetic molecular theory. According to kinetic molecular theory, we know that within the liquid, the particles are little bit far apart. But in gaseous state, what happens? The particles are too far from each other. The distance between the particles is too much. So what happens when this is heated? When I will heat it, this liquid substance is heated. For example, this is water. This water, when it is heated, then when it is heated, then what happens? Again, when it is heated, then the average kinetic energy of the molecules increases, because heat energy is converted into the kinetic energy. Means heat energy, the absorbed heat energy, that will increase the average kinetic energy of the molecules. Now if the average kinetic energy increases, then molecules starts vibrating vigorously. Compared to liquid state, what will happen? Now they will vibrate vigorously. So the intermolecular space between the particles increases. When converted into, when heated, the intermolecular space increases and intermolecular force of attraction decreases. Now the particles becomes free to leave the liquid surface. Now the what will happen? The particles are free to leave the, if it is not enclosed, then they can leave the liquid surface. From here they will leave the surface, okay, and convert it into the gaseous state. So converted into the gaseous state on heating. Even the same thing happen if I will release the pressure within the particle. Suppose a liquid is there, if I will release the pressure, then what will happen? The liquid will be converted into the gaseous state. The best example is the LPG. Within the LPG cylinder, the liquefied petroleum gas, that is in the liquefied state. But when we open the knob of the cylinder, at that time it means by opening the knob you are releasing the pressure. So by releasing the pressure or decreasing the pressure, what will happen? The liquid particles move apart and converted into the gaseous state. So the liquid, when converted into the gaseous state at a particular temperature, then that one is known as the boiling. And this we can explain it with the kinetic theory. Here points are given. Once you go through that, on heating, average kinetic energy of the molecules increases. Molecules start vibrating vigorously, and so the intermolecular space increases and intermolecular force decreases. Thus the particles becomes free to leave the liquid surface, and therefore state of the substance changes to gaseous state from liquid state. Next is that, this is about boiling. Now we will discuss about the condensation. Condensation means the substance change from liquid state to, the substance change from gaseous state to liquid state at a particular temperature. Gaseous state to liquid state. Like for example, the steam or the water vapor converted into the liquefied water on cooling. But this will happen when the temperature decreases. So what is condensation or liquefaction? The process in which the substance changes from its gaseous state to the liquid state at a particular temperature with the release of heat energy. With the release of heat energy, that is known as condensation. On cooling, so that is known as condensation. And the temperature at which the substance changes from gaseous state to liquid state, that is known as the condensation point or liquefaction point. This also we can explain with the help of kinetic molecular theory. Here in the gaseous state, actually what happens? The particles are very far apart. Means particles are too far. Like in the balloon, the particles are there, they are too far. But when the temperature is decreased or when it is cooled down, when the temperature is decreased, then what will happen? The average kinetic energy of the molecules decreases. Average kinetic energy decreases. So what will happen? The movement between the particles slow down. When the movement between the particles slow down, then the particles will come closer to each other. Within this, what will happen? The particles will come closer to each other. And then when the particles will come closer to each other, the intermolecular space decreases and intermolecular force increases compared to the gaseous state. Compared to the gaseous state, force increases, and that is why what will happen, the particles gets restricted, the movement of the particles gets restricted, and they start vibrating within the boundary. They start vibrating within the boundary of this container. Within the boundary of this container they kept, and that is why in this way the substance changes from gaseous state to the liquid state. And this is what this is known as condensation or the cooling, like water vapor converted to the liquefied water during this condensation. Next is that, again recapitulate the points, that on cooling the average kinetic energy of the molecules decreases, movement between molecules starts to slow down, and intermolecular space decreases, and in turn intermolecular force increases, and movement of the particles gets restricted, and they start vibrating within the boundary of the container they are kept in, and therefore state of the substance changes from gaseous state to the liquid state. Next is related to the freezing. In case of freezing, what happens? The substance changes from, in case of freezing, the substance changes from liquid state to solid state. For example, water is there and it is converted into ice, and that one is known as what? That is what? That is known as melting. Solid. So water changes into the ice, that is what? Sorry, solidification or the fusion. So the temperature at which, the fixed temperature at which the substance changes from liquid state to solid state, that is known as the freezing point or solidification point, and the process in which the substance changes from liquid state to solid state at a particular temperature, that is known as the freezing. This also can be explained with the help of kinetic theory. In water, it is actually in the liquid state, so what happens? The particles are little bit far apart, and in the solid state what happens? The particles are very close to each other. So it is when water is cooled, at that time it will release heat energy. When it will release heat energy, then what will happen? The kinetic energy, average kinetic energy of the particles decreases, and we know that when the kinetic energy decreases, the movement of the particles slow down. Now the movement of the particles slow down, what will happen? The particles will come closer. So on cooling, what, the movement of the particles slow down, the particles will come closer, and when the particles will come closer, then the intermolecular space decreases, intermolecular force of attraction between the particles increases. When intermolecular force of attraction between the particles increases, then what will happen? The movement of the particles get restricted, and they start vibrating about their mean position with smaller amplitude, with lower amplitude. They start vibrating at their mean position with lower amplitude. And when the vibration decreases, or the movement of the particles decreases, and when they come closer to each other, it means now the particles are tightly packed. So the substance converted from liquid state to the solid state, or you can say water. If it is in the form of water, then it will be converted into the ice, or if it is in the molten state, anything, then it will be converted into the solidified state. So this is all about that how the substance changes from one state to another with the help of kinetic theory. Again, we recapitulate that we once go through more that how the substance change from liquid state to gaseous state on the basis of kinetic theory. Actually, what happens on cooling, on lowering the temperature, the average kinetic energy between the particles decreases. Average kinetic energy decreases, and so what happens? The movement between the molecules slow down. Intermolecular space increases at that time. When space increases, then the force of attraction between the particles increases, and force increases and the movement of the particles get restricted. They start vibrating just above their mean position with lower amplitude, and therefore the substance converted from liquid state to solid state. So this is all about how the substance changed from one state to another state. Now last is left, that is the sublimation. Sublimation is what? When the substance changes from solid state to gaseous state directly without passing through the liquid state. For example, camphor. All of you are familiar with the camphor. So when camphor is heated, then what will happen? It will not melt. Directly what will happen from solid state converted into the gaseous state. Even the same thing happened with the iodine, or if you will take ammonium chloride salt or naphthalene balls. These are the examples of the substance which converted directly from solid state to gaseous state on heating without passing through the liquid state. This process is known as the sublimation, and the substance in the solid state like camphor, naphthalene, iodine, ammonium chloride, when they are in the solid state at that time, we call them sublimate, and when on heating they are converted into the gaseous state, in the gaseous state is known as the sublime. In the gaseous state known as the sublime. So sublimation is the process in which the substance changes from solid state to which state? Solid state to gaseous state directly without passing through the liquid state. And then when cool down is, then again what will happen? They will convert from gaseous state to the solid state directly without passing through the liquid state. Means the reverse of the sublimation, and reverse of sublimation is known as deposition or desublimation. Reverse of sublimation is known as deposition or desublimation. In the solid state, I said to you, we call them sublimate. This is known as sublimate. And in the gaseous state, it is known as sublime. Now this change of state also can be explained, or sublimation or deposition can be explained on the basis of kinetic flow. Actually, within the solid state, for example, in camphor or iodine, the intermolecular force of attraction between the particles is very low. Just intermolecular force of attraction means actually in this the particles are little bit far apart, and intermolecular force of attraction between the particles is very low. So when it is heated, as soon as it is heated, then what happens? The heat energy on heating, what will happen? This intermolecular force of attraction is overcome by the with the supply of little bit heat energy, and particles break and they becomes free and escape from the surface of the container, escape from the surface of the solid, escape from the surface of the solid and directly converted into the gaseous state. Again I am repeating, in the substances like camphor, iodine, ammonium chloride or naphthalene, which are actually the sublimate, the intermolecular force of attraction between these particles, intermolecular force of attraction between the particles is very low. So when these substances are heated, the little bit energy is sufficient to overcome the force of attraction between the particles. So with the little bit of energy, what happens? These particles becomes free and they escape from the surface of the solid and directly converted into the gaseous state without passing through the liquid state. So this is all about sublimation. And reverse deposition will occur when what will happen? Again, if this gaseous state cool down, then they will be converted into the directly into the solid state. At that time, what will happen? The particles will come closer to each other, but not very close. This is just sufficient to convert the substance. They will come closer to each other this much so that they will be converted from gaseous state to solid state directly. So this is all about how the substance changes from one state to another state. We can explain all this with the help of kinetic molecular theory. So easily you can keep it in your mind. On heating, what happens? On when you heat, at that time the average kinetic energy increases. First thing, when kinetic energy will increase, the movement of the particles increases. Second, when movement of the particle increases, intermolecular force increase, sorry, intermolecular space increases. Intermolecular space increases, the intermolecular force of attraction decreases. What I said to you, when the substance is heated, at that time the heat energy supplied is converted into the kinetic energy. So average kinetic energy of the substance increases. When kinetic energy will increase, then what will happen? The movement of the particles will increase. When movement of the particles will increase, then intermolecular space will increase. And when space will increase, then intermolecular force of attraction will decrease. And when intermolecular force of attraction will decrease, then particles becomes free to move. Means more freely they will move now compared to the initial state and change from one state to another. Means solid to liquid or then liquid to gaseous state. But when it is cooled down, means when you will decrease the temperature, at that time what will happen? The kinetic energy will release in the form of heat energy from the substance. When kinetic energy will be released, then what will happen? The average kinetic energy of the particles will decrease. When average kinetic energy will decrease, then what will happen? Because sorry, kinetic energy decreases, then what will happen? The molecules slow down, the movement of the molecules slow down. When movement of the molecules slow down, intermolecular space decreases. When space decreases, then intermolecular force of attraction between the particle increases. Now when intermolecular force increases, then little bit restrictions will be there for the movement because force increases and space decreases. So now the movement of the particles decreases or restricted. So the substance will change from in a reverse way from gas state to liquid and liquid to solid state. So this is all about kinetic theory, which was to explain about the change of state of matter. I think it's clear to you, all of you. Okay. So once go through the video once more so that it will be more clear to you. Okay.